Hi, it's Cayden Sauce Cubes, and today I'd like to talk about the big three methods and why it should be the big four. Just a bit of unscripted talking. So, if you don't already know, the big three methods are roux, where you make a 1x2 block on one side, you make the same on the other side, you solve the corners of the top, which would be an alg set called CMLR, which means corners the last layer. It's just got an M in it because it ignores the M slice. You then do EO L6E to solve the cube. Then it's ZZ, which involves orienting all the edges, then making what's either a line or a cross. When I do ZZ solves, I normally make the cross as I find it easier to make than the block building of VO line. Then there's also the most popular method, CFOP. This method involves making a cross on the bottom. You then fill each of these individual F2L pairs in. If you used advanced CFOP like I do, you solve the top face in one alg, then you solve the top layer in another alg. That's called PLL. Solving the top face is called OLL, which is 57 algorithms. Full PLL is 21. I know all of them because I'm that good. My contender for the fourth method is ZB. Now, you might think, oh, why do you think ZB's going to be another method up there? I personally think it's going to be up there because it's got the same F2L based approach like CFOP, but it ends in EO or ZBLS, which is solving the FDR pair while orienting the edges on top. So for this case, it'd be like this. You then solve the entire last layer in one algorithm, like this. So I think it should be the fourth of the big three, because, like I said, it's got the block building aspects, well, not block building, but the F2L aspect of CFOP, which is one of the main reasons as to why it's a fast method. It is also algorithm based, once again, like CFOP or something like ZZ, or a variant of not ZZ roux, and the A variant of ZZ, which is, or it's the same ZZ solve, but instead of OCLL PLL, it's ZBLL. Although ZBLS does take a large amount of algorithms, ZBLL is 493, that is counting PLLs, but if you don't, it's 472. For ZBLS, I think it's around 305 algorithms. I'm not sure though. So I think ZB will be a fast method because it reduces the move count of CFOP's average of about 50 to 5 moves, or if you're world class, something as low as about 40 moves. But for ZB, if you get to like super world class, like someone like Chris Tran, Xuan Yi Geng, or Guanbo Wang, you could lower your move count. I personally believe you can lower your move count to something like 35. So, I think it could be a fast method because it's algorithm based. It involves the F2L, like something like CFOP does, and then you solve the top cross, which I'm learning ZB and I use F2L1 and F2L2 ZBLS. So I don't use advanced F2L. So I normally set up to this case here, or for lefty, it's this case here. So I learned those two, and since I don't use advanced F2L, I set up to that case, I then orient the edges, and if I know the ZBLL, I'll use it. But if I don't, for like a set like L, H, or soon, then I'll just do OCLL, PLL. Sometimes you get a PLL skip along with solving OCLL. I personally count that as ZBLL because if you have a cross on top, you have the chance to use the ZBLL alg set, which solves the entire entire top layer along with orienting the corners, and you can only use ZBLL if you've oriented the edges, if the edges are oriented as well. So here's something like pure soon, like this. So you see something like this. The way I do it might be different for someone else, someone who uses lefty algs, but I solve it like R U R prime U R U2 R prime. It solves the top layer. Now that is a ZBLL, but one of my friends doesn't think it's a ZBLL because you didn't have the intention of using a ZBLL. Now I completely understand why he has that point of view, but it's all up to the person who uses it really. And I hope to be a ZB user in the future. So I hope to get as low as sub 6, like some of the people I mentioned earlier, like Xuan Yi Geng or Guamo Wang. Now Timon is switching to ZB. I noticed because in his recent 5x5 world record single of 31.6, I noticed he used ZBLS to orient the top edges. He then used either a Soon or an anti-Soon ZB. But yeah, he also said in his podcast with Luke Garrett, post NAC, that he was going to eventually switch to ZB. Now, there are some solves where he doesn't orient the edges, but that's what I'm guessing is because he doesn't know the out for it. There are some people who know ZBL who will do EO to ZB, which will like orient. So say, yes, let me set up a cube. So say you have this case or whatever, someone might learn the fact that if you orient the edges with the 2-look OLL like this, it would set up to a T case like this, or it might set up to something like a H or a pi or an L. So the people that know not full ZBLL, but a decent bit of it, like T and U, someone I know like Java Cuba or James Alonso, they would do something like EO to ZB. I eventually am going to use ZB, so I won't need to worry about EO to ZB because I'll be using ZBLS. Now, I know it will take me a long time, but I have started learning 2GLL and I've started learning U. I was learning T before that, but then my lack of ALG training made me like forget all of it. So yeah, I started learning 2GLL U, and I'm doing it the way Brina Sun recommends it. What she says is to like get all your ALGs, train a few a day, minimum for me is going to be about 6. She then says to write like notes on it like this. So I've written notes for all the algorithms. What I did is I put the algorithm here plus the AUF to set up. I then put notes on how to recognise the alg. Now it might not be easy for some subsets like Soon, Pi or H, as they don't really have an oriented corner to base the recognition off of. But I have a friend on Discord who knows full ZBLL and is a bit of the way through ZBLS. So they are going to be a future ZB user, and they said they will help me with alg recog. And yeah, that's just basically all I wanted to talk about. Yeah, thanks for watching.